Good morning students, welcome to the next class. In the last class we have discussed about the test function, that is test function means the probability of rejecting the H0 is called as a test function when x equals to x and it is denoted as pi of x, and pi of x takes two values, that is 1 and 0, and suppose if pi of x value equals to some gamma which lies between 0 to 1, then we reject the null hypothesis with that probability gamma, and based on the test function we have discussed about the two types of tests, that is non-randomized test and the randomized test. Non-randomized test means the total sample space is partitioned into two parts, that is omega and omega dash, where omega dash equals to x minus omega and omega intersection omega equals to null set, and omega union omega dash equals to x, that is total the set of values for which H0 is rejected. And phi of x considers only two values, that is phi of x equals to 1 if H0 is rejected, that is x belongs to omega, and phi of x equals to 0 if x belongs to the acceptance region omega dash. And we have studied about the randomized test, that is about the pre-assigned value. So here in this test we are going to assign a pre-level. So a level is a pre-assigned value and we will find out that pre-assigned level by considering some randomized procedures. So that is called as the randomized test. And we have discussed one problem based on the where the critical region was given and null hypothesis, alternative hypothesis is given. We find the type 1 and the type 2 error probabilities. So today also we will continue with the same kind of problems. So in the last problem, the probability distribution is given as the exponential distribution. So instead of exponential distribution, here some other PDF is there and a similar problem. So coming to the question, here given the frequency function, so the frequency function f of x comma theta, so it is a continuous variable, it is denoted with f of x, right? So f of x comma theta equals to 1 by theta. So the function is given as 1 by theta and the limits for this function are given as x lies between 0 to theta and 0 otherwise. So only if your x values, that is limit values. So your x means it is a continuous variable, we will be finding the integral value. So for that limits, if your x values lies between 0 to theta, then you will consider f of x as 1 by theta. So if your x value does not lie between 0 to theta, that means if it is less than 0 or greater than theta, then you will consider the f of x value as 0. So you have to be very clear with these limits, because if out of the limits, if you have any x values or limiting values, then you have to consider the f of x as 0. And for testing the hypothesis, so the null hypothesis and the alternative hypothesis are given as null hypothesis H0 such that theta equals to 1. So under H0, that is null hypothesis, theta value equals to 1 against the alternative hypothesis, that is H1 such that theta equals to 2. Under the alternative hypothesis, theta value is given as 2 by means of a single observation. So here also there is only one observation. Based on one observation, the PTF is given and the rejection region and the that is the null and alternative hypothesis based on the single interval we are going to find for the type 1 and type 2 errors as a critical region. So these two are the two bits given as a critical region, and also obtain the power of test. So in this problem, the extension is we need to find also the power of test. What is power of test? The ability of the hypothesis, ability of the alternative hypothesis when it is true. So it is denoted with 1 minus beta. So anyhow we will be finding the beta value, that is probability of type 2 error. So from that we can find out the power of test value, that is 1 minus beta. So now we'll find the solution for this. Coming to the solution, first write down the given PDF. So given frequency function, so what is the given frequency function? F of x comma theta equals to 1 by theta if the x value lies between 0 to theta or 0 otherwise. So this is a PDF. Now first bit we have to write the next step. We have to write the critical region and the acceptance region. So we have two bits. Under that the first bit, the critical region is given as so critical region, it is denoted with omega. So omega equals to, what is the critical region given here? X value such that 0.5 is less than or equals to x. So the same critical region you can write it as omega such that x value such that x greater than or equals to 0.5. Just for the understanding purpose I have written as x value such that x greater than or equals to 0.5. Now write down the acceptance region. So the acceptance region is given by, so how we will denote the acceptance region? Omega bar. So omega bar equals to x values such that, so here x greater than or equals to 0.5 is the rejection region. So what will be the acceptance region? X value less than 0.5. So now we got our required critical regions and the acceptance regions. Now we will find the probabilities of the type 1 and type 2 error. So first alpha equals to probability of type 1 error. So what is the probability of the type 1 error? The type 1 error, it is denoted with alpha equals to, so when you will be getting the type 1 error, reject H0 when H0 is true. Reject H0 whenever H0 is true. So reject H0 means what is the region we are going to consider here? We are going to consider the axis. So the rejection region is denoted with omega. So probability of reject H0 means alpha equals to probability of x belongs to omega. Reject H0 means x value will be belonging to omega under H0. So under H0, what is the value given? Theta equals to 1. Under H0, theta equals to theta naught equals to 1. 1 into f of, what is f of x value? Substitute f of x value, that is 1 by theta dx under theta equals to theta naught equals to 1. Now substitute the theta value, alpha equals to integral over 0.5 to 1 by 1 dx. So integration of 1 dx is x itself. So therefore alpha equals to integral 1 by 1 is 1, integration of 1 is x. Between the limits, what are the limits here? 0.5 to 1. Now apply the limits. What is the upper limit? Upper limit is 1, lower limit is 0.5. So alpha equals to 1 minus 0.5. So 1 by 2 is constant, integral over 0 to 0.5, 1 dx. So integral over 1 dx means, sorry, integration of 1 is x itself. So beta equals to 1 by 2 into x within the limit 0 to 0.5. So beta equals to 1 by 2 into upper limit is 0.5. 0.5 minus 0 is 0.5 only. So 0.5 divided by 2. 0.5 divided by 2 is 0.25. So beta equals to 0.25. So now for the first bit, we got the alpha value, that is the probability of type 1 error. Alpha value was 0.5. The probability of type 2 error beta equals to 0.25. Next, we also have to obtain the power of test. What is power of test? Power of test. What is power of test? Power of test is denoted with 1 minus beta is given as 1 minus beta, which is equals to 1 minus, what is the beta value? 0.25. So therefore, power of test 1 minus beta equals to 0.75. So for the critical region, so for the first bit critical region, that is x greater than or equals to 0.5, we got the type 1 error probability as 0.5, type 2 error probability as 0.25, and the power of test as 0.75. So copy this one. We'll continue the second bit. Now we'll continue with our second bit. So for the same question and the same data, just the critical region is different. The procedure will be same, just the critical region will be changing. Here the critical region is between two limits. Whereas for the previous problems, we have written the critical region as only one limit. Now the second bit. So for the second bit, we have to write the critical region first. So what is the critical region? The critical region is given as critical region, it is denoted with omega. Omega equals to x value such that, so for which values it is rejected, it is given as 1 less than or equals to x less than or equals to 1.5. So if this is the critical region, how you will be writing the acceptance region? Whatever the values which does not lie between 1 and 1.5, that is the acceptance region. So you may not write here the acceptance region, only critical region is enough. So if you are writing the acceptance region, just you have to write the values which does not lie with this. Acceptance region, omega bar equals to x value such that x values where x does not lie between 1 and 1.5. So if x values lies between 1 and 1.5, then your null hypothesis is rejected. If x value does not lie between 1 and 1.5, then it falls under the acceptance region. Now first we have to find the size of the type 1 error, that is alpha equals to probability of type 1 error. So type 1 error means probability of reject H0 when H0 is true. So now alpha equals to So what is the theta value we are considering here? Under H0, whatever the theta value is there, that one we will be considering as theta. So since if you consider the PMF, since f of x comma theta equals to 1 by theta only for the values of x less than 0 less than or equals to x less than or equals to theta. So here what is the theta value? Other than that, if you have any value, you will be getting the f of x value as 0. Here my theta value, here our theta value is 1. So 1 means here 0 to 1. If your x value lies between 0 to 1, then you will consider the f of x value as 1 by theta. Here if you observe, the limits are from 1 to 1.5. So since x does not lie between, since here x does not lie between what are the limits? Between 0 and theta equals to 1. Since here theta equals to 1, that's why here x does not lie between 0 to 1. Here x values are from 1 to 1.5. 1.5 means obviously it is greater than 1, right? So your x value should lie only in between 0 to 1, but here limit is 1.5. So we cannot consider the f of x value as 1 by theta. So what will consider the f of x value? In between 0 to theta means you will consider 1 by theta. Other than that, if you have any values, then you will consider f of x as 0. So that's why here f of x value will be equals to 0. So integral over 1 to 1.5, 0 dx. So what will be the 0 dx? It will be 0. That is our probability of type 1 error will be 0. So therefore alpha equals to 0. The probability of type 1 error we got it as 0. So now we will find the probability of type 2 error. So note down this one, note down the since part also. Since x does not lie between 0 to theta equals to 1, f of x comma theta equals to 0. Now we find the beta, that is probability of type 2 error. Beta equals to probability of type 2 error. So what is type 2 error? Beta equals to probability of accept H0 when H0 is accept H0 when H0 is false. H0 is false means H1 is true. So which implies beta equals to probability of accept H0 when H1 is true. Beta equals to probability of, so when you are going to accept the H0 under the omega complement, so probability of x belongs to, generally we write accept H0 means acceptance probability. But here the two limits are given. In the starting writing itself I said only the critical region will write for this. The acceptance region will not be written for this problem because we have two limits. Whenever it lies between two limits, then we will write the critical region. That means two limits are already given. So that's why we consider only for the accepting H0 also we consider the same omega, that is x belongs to omega bar. So whether it is omega or omega complement, the limits will be same, that is x value lies between 1 to 1.5. So based on the given limits only you have to write the acceptance or reluctance region. So H1 such that theta equals to theta 1 equals to, what is the value of theta under H1? Equals to 2. So don't get confused here. So it lies, x value should lie between 0 to theta. Here under h1 what is the theta value? 2. So 1 and 1 to 1.5 means it lies between 0 to 2. So you can consider the PDF here. So last for the alpha, it does not lie between 0 to 1. That's why we took 0. But here theta value is 2 under h1. So since it lies between 0 to, our 1 and 1.5 lies between 0 to 2, we consider the PDF. So beta equals to integral over 1 to 1.5. What is f of x? 1 by theta dx, and the theta equals to theta 1 equals to 2. So here theta equals to theta 1 equals to 2. Substitute the theta 1 value. Beta equals to 1 by 2 integral over 1 to 1.5 1 dx. We have substituted theta value, right? So beta equals to 1 by 2 integral over 1 is x within the limits 1 to 1.5. So now apply the limits. Upper limit minus lower limits. So beta equals to 1 by 2 into upper limit is 1.5 minus lower limit is 1. 1.5 minus 1 is 0.5. So beta equals to 0.5 by 2, that is equals to 0.25. So we got the probability of our type 2 error also as 0.25. Next we have to find the power of test. So power of test 1 minus beta equals to 1 minus 0.25. So therefore power of test 1 minus beta equals to 0.75. So for the